This conference will now be recorded.
Okay, great. Good morning and good afternoon, everyone, and thanks for joining us again. This is our third day of training for the Tanzania team, and today we're going to talk about Jupyter Python notebooks, which give us a new tool to analyze the data cube, and I find that the Jupyter notebooks are quite powerful. So if you can get over some of the intimidation of the code and realize that there's tremendous power behind some of the Jupyter notebooks, I think you will find them really fun to interact with, and again, very powerful in terms of the data and information and flexibility that you can get out of these. So, a few things to mention. The other day when we were at the we were working on the user interface in the last 2 days. Behind the scenes of the user interface is all of the code, and this code is written in computer language called Python. And what you're going to see today are some of the algorithms that are behind the code and behind the scenes of that user interface. So many of the things that we'll be doing today in demonstrating these notebooks are essentially the same as what can be done in the user interface, but more flexibility, more power, and more potential to develop new algorithms or new ideas that are not part of the user interface. The user interface is meant to be a high-level, simple way of interacting with the cube, and the notebooks are the ultimate in flexibility. So I call your attention first to a document I sent out, Jupyter Notebooks Tanzania. This is a one-page document I put together to show you how to interact with the notebooks. I'm going to go through all of the bullets that you see here and show you how to interact with these. And when we get to the end, you will have demonstrated 2 notebooks today, Spectral Products and Land Change, and that is what I'm going to show you today. So at the top, I ask everyone, please don't go to this website yet. Let me demonstrate it here today. This website is the same address as our user interface with a :8086 added at the end, and then a password, and those pieces of information will bring you to a screen that looks like this. So when you get to this screen, this is the screen for the Jupyter Notebook. So Jupyter is the Jupyter Hub, or what you're looking at here is a structure where we manage Python code or Python scripts. And when I talk about a script, I mean one of these individual files. So the 2 that you see here that are highlighted in green, these are called notebooks, and I have them open in tabs up here. So when you click on any one of these, they will open. Just a few things to navigate and to understand. When I come to this screen and I see these various notebooks, there's a few that you will have here. There's an ARDC training folder. These are actual notebooks that you had back in May of 2018 when we did some training. I haven't run those yet, so we'd have to make sure that they're still running and that there's no issues. But I hit that folder and I'm back to the top. The 2 new ones that I've created for you today are Land Change and Spectral Products, and I think you're going to find these quite interesting. So when you click on a particular file, it will bring up one of these tabs. As these run, if I go over to the running tab, I can see which files are running and which scripts are running at any one time. When something is running, it is in the memory of the machine, and it is taking up computational resources. So if you leave a lot of these scripts running, they will take up resources and make things a bit slower for others. So when something is not running, I like to clean this up by hitting the shutdown button. And all it does is it closes that from that file from running in the memory of the computer, and it frees up things to run cleaner for other scripts. So this is just a little bit of housekeeping, but something you want to keep an eye on. So I go back to the files, and the first one I'm going to start with is spectral products and land change. One other thing I want to mention is, and you'll see this in the document, when you come to this screen and you are a new user and you would like to play with one of these, what you're going to want to do is make a copy of this. And one way you could do that is to click next to it and hit the button here, duplicate, and it will duplicate the Spectral Products notebook, and you can rename it on your own. And when you rename it on your own, you will have your own one to play with. If anybody comes here and edits the Spectral Products Python notebook, it can be edited on the fly and it'll change automatically. So if someone else comes there and changes it, they could disrupt your work. I would strongly suggest that you take these baseline 2 notebooks and you copy them and add your name to them. So for instance, this is the Spectral notebook here. I'm going to just run to the top. When you get here, this is what it looks like. If I wanted to copy this, I would just do File, make a copy, and notice it opened up a new tab, and here's a copy. And at the very top, if I click on the name of this, I can rename this and say, I'm going to make this Spectral Products Brian, and hit rename. And now I have a Spectral Products Brian, and I can operate on this Python notebook and it'll be all mine. Let's say I close that down and I go back to the folder. You're going to see Spectral Products Brian is sitting there. But I don't want that running right now, so I'll just shut that down. So I only have 2 things running. These are the 2 tabs I have. I go back to my files area, and I still see I have Spectral Products Brian, but it is not running. So that's my file. I could click on this and I could rename it. I can download it. I can edit it. I can delete it. So all these things are possible by clicking to the left. So let's go back now to the top. And this, we're going to walk through what one of these notebooks looks like and the various pieces. So when you look at this, there is a lot of code here in these notebooks. And what a Jupyter notebook does is it mixes a combination of code with output. So here's imagery output, there's output, here's products, here's products. So think about the power here is that the code is there simultaneously with the output all in one place, and it really gives you some great flexibility. What I have done for you in both of these notebooks, in order to simplify the areas that you might need to change, throughout the notebooks, if you search for this tagline, change here with some little arrows and then the bottom arrows, the code in between change here and the bottom arrows is the only thing I would assume you need to change in this notebook. If you become a more powerful user, if you understand the code and get better at running these things, then you can modify many more cells in these scripts. I must admit, I am not a powerful Python programmer. My guys will laugh if I call myself a Python programmer, but in a matter of probably 6 months to 9 months, I've taught myself a little bit of Python enough that I can modify any one of these scripts. I've actually learned how to add some new code and to modify some things. And just by looking at what someone else has created in a script, I'm able to modify some things on the fly and get things to run and create some new features. So these two notebooks were, the core of them were created by my team, because I don't know how to generate, this logic initially, or some of this logic at the top, which things I'm importing in terms of libraries. They know how to do that, but these two notebooks I've set up entirely on my own, and it's very possible to do so. You just have to kind of get over the intimidation factor of this, run a few of them, learn how they work. I think you'll be very impressed with what they can do. So again, much of the code you see here, you will never modify. What you will modify are the areas where it says change here in between these tags, and I'm going to just walk through what they do in each case. So before we run this, I want to show you what the code looks like and how things run. If you see a hashtag in front of a line, that is a comment statement. So that means that that line is ignored. So notice here, hashtag change here. This is just a comment. Platform Landsat 7, product Landsat 7 Tanzania. This is defining the platform and the product that we're going to use. Notice there's no hashtag, so that's real code. It gets executed. Let's go down a little further and look at some more. This is output. So after the code blocks, if you see information, that's the output. So notice this particular block on the screen here. This code here is saying, load up from the utilities folder, data cube display map. Oop, what did I just do? I think I just messed something up there. I'll have to go back and do that. I pulled over some data. So in any event, I load up this data cube display map, and what I get in this area here is the output on the screen, which is the map of Tanzania, and allows me to say, I now know the cube that I chose is the proper cube, and I can navigate the screen. If you want to pick analysis regions for you to do some analytical work, this is where you might want to zoom in, find an area of interest, and identify the lat-long coordinates of the bounding box to do the analysis. So if I wanted to do an analysis over Lake Salunga, I can zoom in over Lake Salunga. If I click on this map, it shows me the lat-long box in that corner, the lat-long box in that corner. And what you'll see in the next block is, if I want to define an analysis region, I need to pick bounding boxes of latitude and longitude, and that's something I do. Let me clean up this code here that I just messed up. I'm going to just pull something up here. You notice I was doing something. I'm just going to copy this to make sure that I don't run this thing crazily, because I copied something strangely. All right, I'm back to where I was. So let's get rid of that one. So if I look on the next block, I have change here. This is an area that you will change. You will select a location with a latitude, longitude, and time range. And notice below what I have. I've set up a number of case studies for you. This is where you can add your own case studies, and you can change the latitude and longitude bounding blocks and the time extent and run your own cases. I've set up a case here for Dar es Salaam. Notice the latitude, longitude, and time extent are not commented out. This is the part that gets executed. All of these blocks are commented out, so these are other cases. So I can remove a comment and add a comment here to change it, and I'll show you how I'm going to do that. Let's go down a little further. Notice I picked Dar es Salaam. Now let's look and see. There is the bounding box, which shows me the analysis region of what I'm doing. So here's the analysis we're doing here. We're doing Dar es Salaam on the coast. Let's go look a little further. By the way, if I started at the top, I forgot to mention, this is importing data cube configuration. This is importing some plotting functions, importing NumPy, Xarray. All of this you will never touch, but it basically imports a number of libraries and tools. And you'll see this all throughout the code. Tools and other scripts need to be brought in order to make these run. But you will see it'll be more obvious the things that you need to change that are simplified. So I'm going to go down a little further and show you what's happening. So as we walk through this code, one of the steps here you'll see is Landsat dataset, DC load. This is one of the more important steps. And this is the step that actually takes the longest. What this is doing is after you have defined your region, it is going into the data cube. You've picked this platform, this product, which by the way, your platform I think was Landsat 7. Your product was the Tanzania cube. You've loaded your latitude, longitude, and time extents all in the prior blocks. This says I want the red, green, blue, near infrared, SWIR bands. And basically it loads up all of that pixel information that you have identified. It pulls it out of the larger data cube and it stores it in temporarily in the memory of the computer so that now we can operate on it and we can do analyses. So when I say it stores it in the memory, what it does is it creates this thing called an Xarray data set. And I just want you to think about an Xarray data set as a multi-dimensional cube. So it's going to take your time extent, your latitude, your longitude, and all of these variables, all those pieces, think of it as a multi-dimensional cube, and it stores it in memory as an Xarray or just, X, Y, time, and multivariables. That's what gets stored in the memory. This tells you there are 2,065 pixels in the latitude dimension, 2089 in longitude, 14 time steps in the period that you've selected. And so we only chose 1 year. So that's 14 time slices. So let's go down a little further and see what we're trying to do. And by the way, this one that I'm walking you through is all about spectral products. And I chose Dar es Salaam because we're going to look most closely at an urbanization product here. This one Python notebook does both water and spectral indices and things like urbanization. So I built it all into one, and so it has a lot of flexibility, whatever you decide to do with it. This is for masking out clouds and shadows, and I can mask out water. And what you'll see here is you can follow this logic. The more you get used to all of this, it'll start to make sense. But basically what I've done is created a land and water data set that just masks the clouds. Then I create a land data set that masks clouds and water. And later on, I use these things. And what I do is I show, here is the land and water composite. It's a little dark on the screen. Don't worry about that. It's just an RGB composite, and sometimes we can lighten these things up. But you can see the coastline and you can see the inside, and the black here is clouds. So there are some clouds even in this final image. This one is a land composite where it masks out the water. You'll see it's a little clear for some other scenes. This particular one is very dark. Now let's go look at some of the products. So again, we have loaded into memory the information we want to do the analysis on. I've shown an RGB image of what this might look like in a typical, red, green, blue. But now let's get to the powerful products. And what you will see, now notice, nothing is being changed by the user. These are just all products that automatically come out. The only thing at the top thus far that you will ever change, again, is right here, you'll change the location of your analysis, and you might change the data cube you select. We have a few issues I see here because it's possible right now in some northern portions of Tanzania, you might have to select the Kenya cube. But once we fix that, you'll probably never need to change this block. It'll always load the Tanzania cube. Let's go down a little further. So the first thing, and we saw this yesterday, this is the fractional cover product. I really like this product. I think it's fantastic. Remember, it's an iterated product that uses a combination of red, green, and blue to decipher. Bare soil will show up as red, and also urbanization. Notice the urbanized area is in red along the coast. This is a view of Dar es Salaam in 2002, about 16 years ago, and I'm going to show you the difference in the years. It's quite significant. So this is 2002 Dar es Salaam on the coast. Areas in green are vegetated. Areas in blue are what we call non-green vegetation. So just think of that as sort of dead vegetation or just non-green. Let's go down a little further and look at some other spectral indices. So this is where you can define your own spectral index. I've defined a few here, and we'll look at the output. I defined NDVI, and if you look back at the document I sent out yesterday, this is the normalized difference buildup index. This is the vegetation index. This is the soil adjusted vegetation, and this is the enhanced vegetation. These are the formulas, and you can follow the formulas and see how these things are built. It then applies this formula and says, for instance, I want to take NDVI, I want to apply that formula to my land composite, and then later on I'm going to plot the result. So in this case, I'm plotting NDVI, which is buildup index. This is going to highlight areas that the darker areas are going to be more bare soil and are going to show urbanization. And if you look at this, urbanization doesn't exactly jump out at me in this product, which is one of the reasons I'm not in love with NDVI. Look at the difference here with this product. I can clearly see the urbanization in red. It's not as clear in a grayscale image here. Let's go a little further and look at vegetation. Now things start to jump out a bit. This is NDVI. This is the most common vegetation index. Few things I want to mention in this image. The white area is obviously the ocean. So this is water. These inland white blocks are clouds. So this is just cloud contamination. You see a river that runs in through here. This is Dar es Salaam. Notice the lighter color in Dar es Salaam in the middle. There's a lack of vegetation here because this is an urbanized area. This is a dense vegetation. Anything dark is dense vegetated. Let's go a little further and look at some other ones. So this is NDVI. A lot of people like to use something called Enhanced Vegetation Index. Notice the difference in the contrast and the variation between this figure and this figure here. This is why Enhanced Vegetation Index is often used by people, and they like this one better. It really does bring out a lot more contrast in dark vegetation, changes in urbanized areas that are lighter in color. This is dense vegetation, likely associated with tree cover. So there's a lot that you can do here to mask out certain types of vegetation. Let's go a little further. This one's soil adjusted vegetation index. Soil adjusted will take into account some soil moisture, and notice the enhancement here, how the area of urbanized area is easier to see here. And so there's some differences here. I urge you to go out online, take a look at, there's a lot of literature that talks about these various combinations of indices and how to use them. I don't pretend to be the authority on the science behind this, but I will say from a visual perspective, there's some obvious differences. So let's go down a little further. Those are land spectral indices. Let's now look at water products. So this is the non-differenced, normalized difference water index. Water will show up as dark blue. You can see the river comes in there nicely. Well, how about WAFs? WAFs is our water product. That's really clear. WAFs is either 1 or 0. It's either water or not water. And you can see a difference here. You can see some areas here that are a river coming in. You can actually see some little spots here that are probably little areas of water, maybe inland water bodies, really small. So the end of this notebook is where it gets interesting, because there's some code that we built here to create a threshold. And nothing gets changed here. And basically what this does is I'm going to define 2 boundaries for a parameter. And this is where I'm going to define it right here. So notice, remember what I said, areas that I say change here, you're going to change some of this code to adapt to what you desire. So in the case here, what I'm trying to do is I'm running a case over Dar es Salaam, and I know that I'm looking for urbanization. Now, I hope I don't make you dizzy here. I'm going to go back here a bit, and I'm going to look at this product right here, which is the fractional cover, and I'm going to try to pull out all the fractional cover that has dark areas of bare soil, or what is also synonymous with urbanization. So the way I do that is I put a threshold limit on the bare soil component of this index. And by putting a threshold limit on the bare soil component, I will be able to pull out, you'll see in a moment, what I do is, it says right here, fractional cover goes from 0 to 400. Bare soil is typically greater than 40 for urbanization. So if I take all the pixels between 40 and 100 where the bare soil is above 40, this is what I'm defining as my min max threshold. You can do this for NDVI, EVI, Savvy, play around with it, and you'll see it's quite interesting. Now, change here is another area, because I can plot NDVI, but since I'm creating a threshold for bare soil, what I'm going to plot is the threshold plot for bare soil. Well, this is actually an urbanization plot, and here's what it is. So look at that definition. That is a really good representation of the urbanized area of Dar es Salaam in 2002. That area right there in red coincides beautifully with the area in red in that image right there. And what I want to point out is a few things you'll notice. And these urbanized areas, it's really looking at what appears to be bare soil. And notice what's happening. Notice along the coast, we know that people live along the coast. We know that there is the density of the main population in the city here, Dar es Salaam, and you see some coastal expansion. If I were to take this threshold plot here, all these pixels in red are the pixels that fall between 40 and 100% in this threshold. And these last bit of code here actually counts up those pixels and plots them out as a percentage and as a volume. So if you look here, the number of pixels inside the threshold are 52,398, and that represents 1.21% of the scene. Well, later on when we do water, this is also counting the water in the scene. You don't have to worry about this one, because right now that's only going to count the water on the coastline. There's not a lot happening. I'm going to show you an example where if we count the water for an inland lake. This was a question that came up yesterday. I think Benedict asked the question of how can I tell the difference in the water volume? I'm going to show you how to do that. So notice this right here. We're going to rerun this code in a moment, but there's 52,398 pixels that I think are urbanized area, and they represent 1.21% of the scene, and this is in 2002. So what I'm going to do here, I've already pre-run this case. This case has already run perfectly fine. I'm going to go up and I'm going to modify this, and I'm going to let it run. While it is running, we'll jump over to the land change, and we're going to watch. We're going to take a look at that one. So let's go back up, and I'm going to change a few things. And remember, I'm only going to change the things that are marked where it says change here. I'm going to leave this alone. I'm still running Tanzania Cube. Instead of Dar es Salaam, or actually I'm going to run Dar es Salaam again. I take that back. I'm going to run a different time period. So from 2002 to 2003, that's basically year 2002, I'm going to change this to 2017 to 2018. This is January 1, 2017 to January 1, 2018. So instead of running the year 2002, this is now going to run the year 2017. Nothing else will change below. I don't need to change anything because I am just repeating this entire code. So how do we run things from the top? We go, this is what I like to do. You can run cell by cell by running cell, run all above, run all below. There's some tricks to running pieces of the code, and I'll show you how to do this once this runs. If you want to run it from the top, kernel, restart, run all is what I like to do. And I'm going to do that, restart, run all, and it is now going to start running this notebook. As the notebook runs, it jumps to the bottom and you will see stars. If there are stars next to the code lines, it means those codes have not yet been executed. That line hasn't been executed. If you're impatient like I am, you can scroll to the top and watch it run. So I scroll to the top. It has run this line. Once a line is executed, it numerically will run the line. So it'll numerically increment the lines. So this code is running. Right now, it's running this code. Block 2 just ran. Block 3 ran, and it gave that plot. Block 4 just ran, and it showed Dar es Salaam. And now it stalls here, even though this block has a little star. One thing I've noticed about the code is that it's actually stuck on this block. Remember that I told you that the process of loading the cube in memory is the part that takes the longest. This is where you need to be patient. This code right here, I ran it last night. I'm going to say it probably ran beginning to end in 2 to 3 minutes. We're going to let it run. It'll take 2 to 3 minutes to run into completion. If there's more people running, or there's more code being running simultaneously, or things are happening, it might take longer. And if you choose really large areas, it might say a memory error. So if you get a memory error, it's saying your analysis block is too large. I would suggest going back and making it smaller, and that is what we found. We found that you've got to turn off a lot of code, and very few things need to be running if you're going to load up a lot of pixels into memory. So while this is running, you see it's stuck on this block. Let's go over to the land change and take a look at this one. So this one's also interesting in that what I did was created a notebook here that is going to use vegetation index, and it's going to threshold the vegetation index, NDVI. And by the way, you could change this to EVI. You could change this to a number of things, and I think it might actually have better results if you play around with what parameters you use. So something I want to do in the future is, instead of NDVI, I'd like to use EVI, or I'd like to use fractional cover. I think both of those would do an actual better job than NDVI by itself. But let's just use NDVI, and let's see if we can identify forests and then detect how the forests have changed over time. So let's walk through this code and watch it. Notice up here, I'm watching this one run. You see the little hourglass? The hourglass on this tab tells me this is running. When this is done, it'll look like a notebook like this. So I can just watch this run, and we'll jump over there when it's done. So we walk through again. Tanzania cube, I'm loading Landsat 7. You can load Landsat 8. It'll just give you different time extents. But Landsat 7, I come down here and I've identified some regions for you. We're going to do 2 regions today. We're going to do the East Jenin Forest Reserve, and we're going to do a Rungwa area near a game reserve just south of Dodoma. These 2 areas I found have a lot of deforestation. These other areas here, I've run prior cases in Usingi Forest, lots of deforestation. These are 2 other areas of the Jenin Forest and an area around Nakuru. You can run these on your own. You will see they work well. Here's the area. This is the area along the perimeter of the Jenin Forest. You're going to see quite a bit of land change here. Now, here's what I set up. Notice it says change here. The way this code works, and you just have to kind of look at the code and see if you can figure this out, but I'm selecting a baseline time period with a start and an end date. So I'm picking 2 periods of time to compare when I calculate land change. I'm going to start with January 1 of 2003 and January 1 of 2004. So if you think about that, that's basically the year 2003 is going to be my baseline. I'm going to compare that to the year 2017 is going to be my analysis time period. So I'm going to do the baseline, and I'm going to compare it to the analysis. By the way, I just noticed at the top, this looks like it's almost done. There it is. Spectral Products is getting near the end because it's looks like it's finishing. So the baseline product here, I'm going to create a mosaic that is based on the maximum vegetation index for the baseline and the analysis time period. I want to use max NDVI because I want to enhance the vegetation. I want to compare each of those time periods with maximum vegetation, and I'm going to filter out what I think is forests, and then I'm going to compare the difference between the two. So let's go down further. Notice nothing gets changed here. This loads up the baseline cube, loads up the analysis cube, it does some things with the X-array. It cleans up the data and removes clouds. Again, you will not have to modify any of this, but you can look at the code and see what it does. And it creates a mosaic function. Notice here where it says, anywhere you see from utilities, data cube mosaic, import these functions. This is basically importing code from the utilities. If you come over here to the home and you click on utilities and go to data cube utilities, you will see a huge number of Python scripts. All of these scripts are what are being called out when I load in something here and I say create max NDVI mosaic. That is a Python script in this folder. So think of these as libraries. This is a utility library. Instead of listing all the complicated code here, I actually call the code in my script, and it allows me to do a lot of powerful stuff. So what it does is it keeps these high-level scripts clean and allows you to call in things as you need them. You can always go look at what this code is doing, and trust me, it's a lot more complex in the background. Here's another one here where it's calling from the utilities folder, import RGB. There's an RGB Python function that basically creates this plot. So this is the baseline plot. I want you to look at the greenness around the perimeter of the forest and how wide it is. There's a little bit of noise in here because these are not super clean images because these are mosaics. It does the best it can. And look at that comparison there. This is the analysis composite in 2017. Look at how the forest has a crisp edge and there's a lot of dark or a lot of dry area here. And look at how much larger the forest was back here. The greenness expands significantly. Let's go down and look at what else is happening. That's just a visual interpretation of what's happening. I define NDVI. Now, the first thing I do here is I create a threshold. I have arbitrarily said I think forests are between an NDVI of 0.6 to 0.9, so that's going to be my threshold. Basically, what I'm going to do is I'm going to mask out all of the pixels between 0.6 and 0.9 NDVI. When I do that, it looks like the following. That is an estimation of what I think is forested cover in dark green. Areas that are non-forest are white. So you're going to see some areas here that the code says, I don't think that's forest. This area they believe is dense, dark vegetation and it's forest. I'm only going to do the analysis on the areas in dark green. I don't care about the areas in white. And let's see further what happens. The next thing I do is I create an anomaly product. I want to compare the baseline time period to the analysis time period. I want to subtract the analysis minus the baseline, and voila, this is the result. This is where it gets really interesting. This is a plot of the change in NDVI. If NDVI is going down, if I am reducing the vegetation, it's going to be red, and you will see all the areas in red have drastically reduced. All the areas here in lighter colors, there's no change. And I will assume that these areas in red have been deforested, or at least in my mind, there's a significant change in the vegetation. There's no doubt there's a change in the vegetation. Let's go further. I take this anomaly product, and the last thing I do is I say, what if I only filter out of this product here things that have changed significantly. I'm looking for a change between a loss of 0.2 and a loss of 0.6. And then finally, I create a complete threshold product, and there's my final solution. This product here is quite impressive because it says everything in red is a significant loss in vegetation. Everything in black is still remaining forest, and everything in white is considered non-forest. There is a lot of loss of vegetation here, and what I can do is I can count up, and in the end, you'll see there's a threshold count. This is the number of pixels, 65,219 pixels have been devegetated, and the percent inside that threshold is 40%. So 40% of that scene has significantly lost vegetation over that time period. So this is East Chenin. I want to show you, I did this last night. I compared the results of our product is on the right, and on the left is something called the Global Forest Watch. If you go out and you Google Global Forest Watch, you will find there's a map that an individual by the name of Matt Hansen creates, where he has a more complicated algorithm. By the way, the algorithm is not free and open. No one knows the magic behind it. But the first thing he does is he screens out what is forests. So I only screened out forests by saying I'm going to consider everything as forest is a vegetation between 0.6 and 0.9. That's a pretty coarse way of determining forests. So if you had a good forest mask, you could apply that forest mask in the data cube and do a better job of initial screening. But I want you to look at everything here that he says in red is deforestation over the same exact time period that I ran in this analysis. This area highly devegetated and all around the perimeter, and I'm getting all that same sort of results. I'm getting, notice the area here shows up here. The vegetation loss here is very obvious, and the vegetation loss here is very obvious. So what's happening over here? Well, what's happening over here is I'm suggesting that there's changes in vegetation, but he's saying these areas aren't even trees to start with. And that makes sense, and that's perfectly fine, because I was not masking with a complicated forest mask. I was only masking based on what I thought was dense vegetation. Let's go back, and I want to look at this, and I'm going to rerun this analysis for a different area. And while this analysis is running, we're going to go back and look at the spectral products, because that just completed a new analysis. I'm going to go to the top, and the only thing I'm changing in this is instead of running East Chenin Forest, watch how I do this. I add a comment here, I add a comment here, and I remove the comments for the Rungwa region. And now I'm running the Rungwa Southern Tanzania Game Reserve. I'm going to run that region instead of East Chenin. I'll keep it to the same time periods. By the way, I'm not going to change the time periods. I'll stick with 2003 to 2017. I'm going to go up, I'm going to do kernel, restart, run all. And I'm going to run the whole thing beginning to end, and there it goes. Notice the hourglass, it's running. Let's jump back to spectral products. Remember what we did here. What we did here is I had run urbanization from 2003 for Dar es Salaam, and then I ran 2017. Let's go back and look at the difference. If you remember the Dar es Salaam urbanization, look at how much larger the urbanized area is. Remember in the prior scene, it was quite a bit smaller. Notice how dark area in red is much larger, a little bit more on the coastline, not so much, but certainly the city of Dar es Salaam has grown quite a bit. Notice again, dark green vegetation, blue is vegetation that's non-green. You can see a lot of differences here. Let's go back and look at the various indices. I can look at NDVI, Enhanced Vegetation Index. That's really a nice product there. I can look at Savvy, soil adjusted. I can look at the water product. And let's go ahead and look at the final result here. because we're going to rerun this one as well. So in this particular case, look how much larger Dar es Salaam is. And if you compare that picture of urbanized area, there's actually a product out there by the European Space Agency. It's called the Urban TEP, T-E-P. If you go out and look for the Urban TEP, you can compare this figure, and I should have done this, I forgot to do this last night. This is actually a pretty good representation of the urban footprint. It does a really good job. I'm actually quite impressed by the simplicity of this algorithm for finding the urban area. And all this is a bare soil threshold using the fractional cover algorithm, which is better than a straight index. It does a better job than the NDVI. Now let's count the pixels. Remember before, there were 52,398 pixels that were urban. If I go down here now and look how many there are 205,000, 205,717. And before there were 52,000. The area that is urbanized is 4.6%. Before it was 1.2%. So I want you to think about the difference between it. If I just compare the pixel count before in 2003 to the pixel count of the urban area in 2017, a time span of 15 years, this area has quadrupled in size, 4 times the number of urban pixels just by doing this analysis. If you actually go and look at the population change between 2003 and 2017, you'll see it also drastically grew in size. It more than doubled. I think it probably is also on the order of 3 to 4 times. The urban footprint is 4 times larger in 15 years, and it does a pretty good job of finding that. So while this is running, the land change is done. We're going to set this one up to run. So notice I'm kind of running these things. Instead of running 2 at once, I'm running them piece by piece. I'm going to run this one now for a water case. So pardon me for scrolling back up and making you dizzy. But I'm going to change this one. Instead of running a Dar es Salaam urbanization study, we're going to do a water analysis. I'm going to do a water analysis over the Matera Reservoir. I'm going to change the latitude and longitude for the Matera Reservoir. And I'm going to start with 2002 to 2003. So this is year 2002 Matera Reservoir. Now, I think it was Benedict that asked yesterday, how can I count the volume of water, the water pixels? Well, this is how you do it. So I'm going to show you. There's 3 different water cases here, and you can try these out on your own. We're going to do Matera Reservoir 2002 to 2003. I'm going to do kernel, restart, run all, and this is now going to run a water analysis for the Matera Reservoir. So notice that same code was just running an urbanization analysis, but built in the same code when you get to the bottom is also a water analysis. Let's go over to the land change. Oh, it crashed. I hope I didn't have a memory problem. Ah, look at that, Andrew. Memory problem. So we're going to see if this runs. I might have to shut one down. If you get this problem here and you get an error that looks like this, memory error, it scrolls to the bottom, it says memory error. That says there's too many things running simultaneously and it won't execute. So I'm a little worried now that this actual spectral product won't execute. I hope there's nobody out there running any cases, but let me just shut that one down. Let me delete that one, the Brian one that I made as a copy. And I'm going to shut down the land change one temporarily. And let's just see if the spectral product finishes. Like I said, sometimes there's memory issues. We're trying our best to enhance the memory on these machines so that you can run larger analysis cases and more simultaneous users can run at the same time. But you run into this from time to time. Either your area is too large or there's too many people running simultaneously. So remember the address here, 54.146, this is also shared with the user interface module. So if the UI has a lot of people running sample cases on the UI, and there's a lot of people running code there, and then someone's trying to run Jupyter Notebooks at the same time, there could be some issues. And so I've run into this from time to time, and like I said, we're trying to play with this and figure out ideal ways to optimize the memory so that these things run well. But there's no magic here. It's just if we bought bigger machines, they cost a lot more money to run. So while we're sitting here and waiting for this to run, let me just open it up for any questions. Are there any questions out there now? This is a good time to take a pause. And Andrew, Syed, Sanjay, if you're out there and have any comments that you'd like to add, please do.
I'll jump in really quickly, Brian, and just mention you were talking about the memory limit, and we plan probably this weekend to double the available memory, so people will probably see that next week.
Fantastic. I think everyone will certainly appreciate that. Thanks, Andrew. Yeah, it's we're just learning how to do this. We're learning how to do this within a cost-efficient manner, because if you think about it, if we just created these massive memory machines out there, we would blow through all of our credits, and we would not function quite as well. Let's see if this thing finished. I can only, let's see, I'm gonna just see if, yeah, great. This one worked, everybody. So let's go take a look at this one. While that's running, I'm gonna go back and rerun this land change one and see if it runs. Maybe it'll run now. Okay, let's go back and talk about the Spectral product. And this one's really cool. So again, this is a water case. So let's see what we did. I changed it to run the Matera Reservoir 2002, 2003. There's the Matera Reservoir. It loaded up the data in the memory. There's a beautiful cloud-free image. That is just very impressive. And remember what I said, and we've noticed this when we were looking at the user interface. The Landsat 7 mission started having some problems in about the middle of 2003, 2004. So some of the early scenes in 2002 have none of the banding, and they're just magnificent images. So this is a really clean, beautiful image, and you see how nice it is. That is the initial image. There's the image with the water masked out. So you can see that's actually a land-water mix. There's the true water. This is the fractional cover. Notice the vegetation is really green on the edges of the water. This is a combination of bare soil and non-green vegetation. And you can look at other indices. This is a buildup index. Well, that doesn't mean a whole lot for water. There's a vegetation index. You can see dark vegetation near the banks of the river, of the reservoir. These are grasslands out here. That's an EVI, which does a much better job of finding dense vegetation. And in the end, you keep on going, you get a water product, and there's WAFs with the water observation from space. And let's count the pixels. And did this one crash again? Yeah, this one has a memory error. So I'm having another memory error problem here. It could be, Andrew, that the area that I chose here for this Rungwa, which I had a problem with this last night, it's just a little bit large of an area. So any event, we'll work on that one and get that one running again, and I'll show you what the results look like. But I want to come down and show you that we did a problem here because I was doing fractional cover, and I don't want to do fractional cover here. Well, I can do this with a bare soil one. That doesn't matter, that thresholding. I want to count water pixels. So what I want to do is I want to count I'm just trying to look and see here in my spectral product. Oh, I don't have the water index piece in here. Did I do it at the end? Yeah, here it is. I take that back. That's one's counting some of the other index. You see this plot right here. This is the water observation from space, which is called WAFS product. I want to count all the dark blue pixels in here, which are only water. And at the very end, you will see some logic, some code here called water counts. So here's what I do. I know that I've got a threshold here of NDVI 0 to 1 for water index. That one I think doesn't do as well, but the WAFS one, WAFS, whenever is water, is 1.0 exactly. So if I create a threshold between 0.9 and 1.1, I will capture everything that is a 1.0 value for the WAFS algorithm. WAFS algorithm stands for water observation for space. And what I get is if I count the pixels here, this is counting the number of dark blue pixels in this product, I get a total of 608,000 pixels. And by the way, every pixel is 30 meters square. So you could essentially take 608,339 and multiply it by 30 and by 30 again, and you'd get the surface area of the water pretty closely. But I'll just say that 24.6% of the scene is water. So 24.6% of the scene is water in 2002. Let's go back and rerun this one for a different time period, and I'll do it for 2017 to 2018. And this one hopefully will run. Unfortunately, the land change did not. The case I was trying to run here with the Rungwa forest, and I'll try to get this one running later after we get off the phone. We'll do some tricks here and maybe free up some memory. But let me show you what that product looked like while this other one's running. Here's the product, and I was really impressed with this one. Here's the product for Rungwa. If you go look, here's the solution here. Everything in black is non-forest. Everything in black did not change. Everything in white is non-forest. Everything in red is something that I thought was forest and actually had been deforested or changed. I want you to compare the red in the image here to the right. This is the solution from the data cube compared to the Global Forest Watch product from Matt Hansen. That is an amazing comparison that I would say it completely matches his output. So look at the structure here, because this area here in this forest, this reserve, this is a game reserve, it's almost entirely forested area. And so I get the area here on the bottom, I get an area here with a hole in the middle, and I get that here. I get this little structure up to the top right, very clear in terms of the edges. All the edges match beautifully. So again, this is a product created out on the web that much of the world is using to look at somebody's estimate of forest change. You can do similar estimates with the data cube on your own in any portion you want and do them on the fly and have a lot more control over how you identify forests in the first place. So there's some things we can do if you come to me and said, I have our own forest mask, or I have a way that we can distinguish forests that's better than just doing an NDVI threshold, then we can apply that and add it to the code so that the forest is masked initially, and then you can apply an NDVI change to a masked forest. I will bet that his forest loss right here is based on some sort of vegetation index change over time. Because what he does is he classifies the forest initially, and then he detects later on that there's no longer vegetation in that location. And so I will bet that the way they distinguish the devegetation is quite similar to the way we're doing it, but the way we mask forests initially is a bit different. They do probably a little better job of masking, because you see right here, they say this is all non-forest. Well, I don't have all that well defined. Let's go back and see. The spectral product is still running. Let's see what it's doing. This is the water product. So it's stuck. Oh, it just ran. There's the lake. If you notice, the lake is a bit smaller. Remember, the lake came way down here in 2002 and 2003. You see how much smaller the reservoir is? This little inland river is completely dried up. There's no water there in 2017, 2018. The only area of this reservoir that's getting fed water is coming in from this portion here. So this is an area here. So let's go down and look and see. It's now finished. Fractional cover product looks really cool, very bright. Dark red, bare soil. So these are riverbanks that have dried up. There's still some vegetation here. So because this once had water, the underlying ground and soil is still moist. There's still some vegetation in this area, but there's no free running water. Let's go down a little further, look at the final product. Remember, we go to the very end. I'm going to skip through these indices. And if we go to the very end, this is the water observation from space product. We're going to count those pixels at the very end, and I want to tell the difference between the two. Here's the very end where we counted the pixels. We said, I want all the pixels that are 1.0, so I just create a threshold between 0.9 and 1.1. That'll capture everything that's 1.0. 423,053. Remember before it was like on the order of like 500 and some thousand? This is now 17% of the scene is water. I wrote it down, if you recall from the prior analysis, 24.7. This number was 24.7. It is now 17.16. A comparison of those years. So from 2002 to 2017, there is a 7% loss in the water volume, or the water pixels in this area. So you could take that and multiply the number of pixels that are lost by 30 and by 30 again, and you could find the total surface area of water lost between the two time periods. So this is a way to get at water extent and change in water extent. And notice, these areas here, these thresholds here are for land changes. The thresholds at the very bottom are for water changes. I urge you to take a look at those and try those on your own. But you can see that they've run quite nicely, and I was able to demonstrate for you some of the land change products for NDVI. So I'm going to stop at this point and just entertain any questions. And I hope that you all go out and give these a try on your own. Again, when you get there, I want you to copy these files and create copies, add your name to them. And if you have any issues, please contact us. Let us know what your problems might be, and we can help modify those for you and help you move along. So are there any questions at this point? Because that's all I had for today, and I hope that you found that to be a valuable introduction to the Jupyter notebooks. I love them. I think they're really powerful and incredible what you can do with them. And it just gives me a lot of products all in one location. If we can resolve some of these memory issues, these things are going to run quite nice.
Brian, while people are asking questions, you may want to, through the menu there, just go into kernel and shut down the kernel for your Spectral product, which will get it out of memory.
Yep. And then try land change.
Yeah. Yeah.
Let's do it again. Sounds good. While this is while we're sitting here, we'll see if that runs. Any questions from anybody out there? What was your impression of this? Do you think that you might feel comfortable enough to try this on your own and play around with it? Or do you think that some of this code's a bit intimidating? You'd rather stick with the user interface tool? Tell me your thoughts on this. I'm curious to hear, because it is certainly a step up in complexity and complication, but it's also a step up in flexibility and power.
Brian.
Yes.
I'm talking from Tanzania.
Mm-hmm.
Yeah, this tool looks very powerful, but the problem is that most of people does not understand the programming language.
Right.
So we hope that it's better to stick on user interface while learning this Jupyter interface.
Understand. So
yeah.
Our plan is to try to add more features to the user interface to do some of the things that you're seeing here. So right now, many of these Spectral products that you see are possible in the user interface, but they're only possible one at a time, right? I can only run that one, or I can only run this one at a time. But what you get in the Jupyter Notebook is you see them all at the same time. And so we're going to run that along with some of these land change analyses. And by the way, it looks like it might be running, Andrew. I forget where it crashed last time, but so some of these things will be added to the user interface. What I want to point out, Benedict, is that if you walk through some of this code and see it, I've tried to make it really clear the portions of the code that you need to change. And frankly, there are not that many areas. So yes, the code is intimidating, but I'm saying there's very few pieces of it you need to change. And really, this spectral block here, the only thing I would change is I could add in new regions with latitude, longitude, and time extents. I could do that just by cutting and pasting and adding in some new spots on my own. So that's something you can do. And then down later, you can modify some of the output by changing some of the thresholds if you wanted to play around. So there's very small chunks of code that require change, very small. Let's go over to this land change and see if it ran. It's still cranking along. So it might finish. Yeah, it looks like portions of it are running. Yeah, it looks like it'll finish up. Here it goes. It just ran. Everything in green is forests. There's the anomaly plot. You see the red there? And I get down to the end, and there's the beautiful final product. So that one ran. And the reason it ran was Andrew said, why don't you shut down the spectral products in memory, run the land change, and voila, that did the trick. So again, Benedict, I agree some of this code can be a bit intimidating. It's all a matter of what you feel confident with. The user interface is certainly the place to start. So I would suggest becoming comfortable with that, becoming comfortable with those products, downloading GeoTIFFs, creating mosaics out of the user interface. That's a great place to start doing some of your analysis in ArcMap. But if you have new ideas, if you have a new algorithm you're thinking about or something you'd like to try, there are things that we could build for you in these Jupyter notebooks that you could then run that might not be in the user interface, but might give you some incredible power. Any other questions that you might have today?
Okay, thank you, Brian. I have a few questions, three questions.
Mm-hmm.
The first one is regarding the counting the pixels. There is pixel outside and the pixels inside. Is it outside and inside of the range.
Yes. Yes,
That is-
exactly. It's outside and inside the range. So if you look here, you see this here in red on the screen. Let me turn off my camera. The red here on the screen, if I go down, what this is saying is there's 424,000 pixels that are inside the threshold and 4,131,000 outside the threshold. This is the percentage. There are 8.9% in the threshold, 87% out of the threshold. So that means it was counting the red pixels are the ones in the threshold, the white and the black are the ones out of the threshold. And that's exactly what you're seeing down here.
Okay, thank you very much. Another question is regarding on how to transfer the map product from this code to include them in any report, whether in
Right.
do we,
so do you want that? Do you want it in just, one way I do it? So there's a couple ways. We could add a little code at the end, very simply with a line or two of code that would take this product and write a JPEG or solution. Do you want this product in GeoTIFF so that you can look at it in ArcMap, or do you want it in just an image that you could put into a report?
I just want it in both, in GeoTIFF, so that probably I can even delineate based on the boundaries, the exact boundary, for example, of
right.
the protected area. Yeah. But I also put in JPEG just right away from this code as well, which is it's a bit difficult to me. Yes.
Right. So okay. So let me answer those questions for you. One thing you can do is if I right click, so I'm on this image, if I just right click right here, I can do a save image as. Most computers will allow that. It'll just take what is in this block and it will save it to my, if I do a save image as and I put it on my desktop, I think it will do that. Okay. Let's see what it looks like. There it is. You see that? It came up. So all I did was I right click, save image as, and that is the way to get the JPEG image quickly onto your desktop. Okay. If you have a Mac computer or a PC, the way I do it on a Mac is there's a few keys that I can actually grab something like that, and I can copy it to my clipboard, and that's another way. That's the way I do it. So when I created for you guys this right here last night, I just grabbed it off the clipboard, and that's how I did it. What I will do for you is I'm going to add some code here that after this threshold product is produced, or this product right here, which is the NDVI product, I'll get my guys to add some code in here that will create a GeoTIFF output for these products that are created on the screen. Because I think a GeoTIFF output would be pretty good. And then you could pull that GeoTIFF product over into your ArcMap tool and go down to the, pixel level and look at the details. Now this one's a little bit, dirty because it's got the lines through it and so forth, but you can see the boundaries quite clearly, and then you'll be able to track those to a lat-long position quite nicely.
Okay, thank you very much for that.
You had another question?
Yes, I've got last two questions. The first one is regarding the threshold range for woodland. We know that the forest is 0.6 to 0.9. That's what we have been using. Mm-hmm. Now, is the woodland outside this range? Is it included?
Outside. So the way I build the threshold, and there's something I'm planning to add to this, because I'm not convinced that let's go back to where this is working right here. Here's the threshold. What I said was, I defined this thing NDVI, and I said, I'm going to take NDVI between 0.6 and 0.9, and I'm going to consider that forests. And I'm only going to use pixels that initially, in the baseline image, that initially fall between 0.6 and 0.9. And when I do that, this is the threshold product that I'm looking at. So basically everything that's dark green, I'm going to consider dense vegetation, and everything that's white doesn't meet that criteria. What I think that's a pretty coarse way of doing it. It tends to work pretty well because most people will agree 0.6 to 0.9 is typically where forests lie, but not always the case. What if instead of using NDVI, if I used, let's go back and look at this product, because I really like the product here, which is a fractional cover. This is an iterative thing that does a really nice job. Fractional cover does a really good job of picking out the dense vegetation. And I have found in forested regions that this fractional cover product does really nice. So I'm thinking of actually building a little modification to this where instead of screening using NDVI to create this, I might put in here fractional cover, and I use 2 different numbers for fractional cover, and it might do a better job of screening out the forests. So I'm going to play around with that, and one way I can do that is if you look at this East Chenin forest right here, I was considering a lot of this area as forest, and notice there's a big block in here that is considered non-forest by Matt Hansen, and a big block here, and big blocks out here. I wonder if fractional cover would do a better job of screening some of that out. I don't know, but it's worth testing. So I hope that answers your question that 0.6 to 0.9 means that's what I'm considering initially as forests, and only things inside of that band are going to be performed in the calculation.
Okay, thank you very much, Brian. My last question is the way we can use this user interface. Are we allowed to, for example, when we go back to our working places, are we allowed to at least teach our colleagues something which we know already regarding how to use this user interface, and maybe allowing them to access, to have the password so that they can start using it?
Right, for programming and working on?
Just the user interface, just by...
Oh, just the UI, just the UI. Okay, so let's go over to that UI real quick. It's right here. There's the UI, right? We were there yesterday. This is open to anybody. So this is an African Regional Data Cube UI that's shared by everybody. And so when you go here initially, I'm logged in right now, but if I logged back out, you'll see at the very bottom in the initial login that you can create your own user account. So this address right here is available to anybody, anybody on your team, anybody that wants. They can go in and create their own username, and they just basically create an email, a username and password, and then they log in with their email address. So anybody can use this. There's no restrictions. What we have put restrictions on are the Jupyter notebooks. They have a password right here. It's at the top of that document that I sent out today. And so the Jupyter notebooks, you want to be a little bit more careful because you can do a lot more damage in those, and a lot more things can be done. So I would say only give the Jupyter notebook information out to those people that you trust are adept with the code and really want to dive in and try some of this. But otherwise, that website here, which is just the append, that's just the initial numbers in that string. This user interface can be used by anybody. You can use this for teaching. You can use this for anybody you want. Now, I will say there's another one. So this one here is just the African Regional Data Cube. There is one here that is Open Data Cube for everybody, and I'll put it on the screen, but it is, here's what it is. It's, I'll just add it to the top here while we're sitting here. It's tinyurl.com/datacube.ui. Write that down. That address, tinyurl.com datacube.ui, will take you to a different area that you could use for teaching that actually has cubes all over the world. And it actually has a user interface that has some memory that's a little more powerful than the African regional. So if you go here and look at Data Cube Manager, there's data cubes all over the world. There's some cubes here, there's some cubes in Colombia, there's some cubes up here in Switzerland, they're all over, some cubes in Vietnam. It all does basically the same thing as yours, so you can run, water detection, but look at all the cubes that are out there. So this is just, you might want to use this one for training because it'll allow some diversity, but feel free to use the African Regional Data Cube for other people, for training and for working on, because we want people to use these sites.
Okay. Thank you very much.
Okay. So I'm going to take an action based on your question. There's two things that I want to do here as a follow-up. Number one is to add a GeoTIFF output, some code in the notebooks to get you a GeoTIFF output product for the things that are shown on the screen. When we do that, I can send you out an update. I'll probably create a separate notebook that just has that in it. And then I'm also going to probably add enhanced vegetation index and fractional cover to the thresholding so that there are other options for thresholding besides NDVI, because I think it might yield some more powerful results. But those two, I think, would be really good additions to the land change notebook that you have. And then for spectral products, the same way. I don't think there's anything here other than maybe outputting, but see, you can use the user interface. So if you wanted what I'm showing on the screen, if you wanted this product here to be output the GeoTIFF, I would suggest using the user interface to output this product. So if you want the original the original GeoTIFF, use the user interface. That's a good way to do it. But for these land change products, which are unique, like this product right here, it's unique to this code. Those we can do separately and create a GeoTIFF for you. Any other questions out there?
Yeah, just some few, Brian.
Yes.
Yeah, we are very much interested in using this tool to identify the illegal cultivation which is now ongoing in some of the national parks.
Mm-hmm.
So do we have to use the similar methods that we have to use to identify deforestations, or there are some other way or approach that we can identify those illegal cultivation within our national parks, in particularly Ngorongoro Conservation Area, which is very, very important for our country.
Right.
That's one. The second one.
Yeah. Yep. Okay.
And also there is a problem of population increase in some of the area. As we know, we are not supposed to live in that particular area. So this population increase as well, how can we use this tool to identify those
right
in some of the area? Yeah, and even including as well as cattle keeping.
So there's a few.
I have another one.
Oh,
I have another one. The other one is this one. Of course, we missed. There is a problem now of erosion in some of our national parks, but we did not at least have anything about how can we use this tool to identify those erosion areas so that we can tackle them to reduce the erosion within our national Yeah.
All right, so a few things come to mind. I've been talking with my team here about adding some features to the user interface to allow you to do these things. For instance, this land NDVI anomaly, we're going to change that in the next couple weeks to do some of the things that you're referring to. For instance, I would like what you see on the screen right here. This is a vegetation anomaly product. It's fairly easy to do. I would like this kind of product to be available to you on the user interface. So think about this from what you just told me. Illegal deforestation, population increase, and erosion identification. I think all of this could be done fairly easily by looking at a land change comparing 2 points in time. So if I compared year 1 to year 2, and I compared 2 time periods, and I did a plot of an area, and I picked a spatial area, and I said compare last year to this year, I could look for illegal deforestation by a product like this, or I could just look at the vegetation loss, and I could see areas in red would pop up, and I could zoom in and start to investigate areas where I see large changes. That would be one way. Just deforestation could be done just with an NDVI product, or possibly like EVI or fractional cover. Population increase, I have been playing around a lot with urbanization. And I really think that one of the best ways to do it is with this fractional cover product. And if you recall when I was showing you that Dar es Salaam case, the fractional cover masking does a really nice job for that. So I have asked my team to look into a feature we can add to the user interface that would allow you to pick just the way we do it here in this tool. The first thing is I would mask out a range. I'd pick a spectral index. So you could pick NDVI or you could pick fractional cover. I would then mask the index. And then the next thing I would do is to say, show me the change, the delta change. And then the change product would look like this. If I could add those features to the user interface, I think it could do everything that you just asked, because I could get at illegal deforestation, looking at changes in indices. I could look at population increases by probably masking things with the fractional cover product. And erosion's the same way, because erosion, let's look at this spectral product. Erosion right here, if you look at this on the screen, anything that shows up as bare soil is going to show up as dark red in fractional cover. So if you are in the middle of an area like a national park that has suddenly become eroded and devegetated, it will show up very clearly using the fractional cover band, because it's going to show up as either dead vegetation, which is dark blue, or if it's truly eroded, it's going to look like bare soil and it's going to be red. So if we could use the visual interpretation of the fractional cover product along with a way to mask things and say, okay, just show me pixels that fall between the range of 40 and 80, you'll be able to pick out these spots really clearly by running a little analysis case in any place that you want. I hope that sounds like a good solution. Would you like to see this in the user interface? It sounds like that would be a great place to put all this.
Oh, sure.
It would just be easier to run, I think. So I think we could do deforestation, population, and erosion control quite nicely within the interface, and I'll talk this over with my team. There's also one really important thing that needs to be done for all of you, and that is we've got to update your data. The data that you have now only runs through the beginning of 2018. We need to add new data for you, And we're in the process now of getting new data added to the cube, because we've got to get that automated. We've got to get that worked out so that new data is being added. And if you go in and you run the user interface this week and you run the user interface again 2 weeks from now, there should be new data in there. And in the perfect world, that's what we want it to be. We want it to be constantly adding new data. So this is something we're working on.
Okay.
So you've given us some good ideas and some good things that we want to work on. But again, if I could, I'm thinking one of the ways to do this is we can kind of prototype these things in the Jupyter notebooks, but adding some of these features to the user interface tool would allow you to download the GeoTIFF product. It would allow you to do things anywhere on the fly without having to mess with the actual source code. So I'm thinking this is the way to do it.
Okay, thank you very much, Brian. Again, of course, the way as we can see now is that most of people, they may be very, very interesting to make use of this tool. And we suspect maybe if we might be many people at a time, will it be possible for us to run?
Many people?
Yeah, maybe, because we have university people, and then they have the interest to go and start now teaching the students there.
Sure, how to use it.
To use them. So what can you suggest anyway? Will it be possible? Or maybe there is any possibility, or maybe any interface, whatever, I don't know, at least that we can maybe communicate or maybe control a little bit so that, we may have time for us and maybe a chance to at least make use of it. Otherwise, if we can say, okay, let us, all of us, to get into it, I believe maybe something, it may not work. I don't know. Well, what are you suggesting?
So we're working on trying to make the performance of all of this better and better with time. We're learning as we go. So as I said in the beginning of all of this is also a little bit of a learning process for us, how to optimize the cloud computing framework behind the scenes, because this is all run on Amazon Cloud. And we've learned that the user interface you're looking at right here, if I have 5 people running jobs simultaneously, it doesn't do very well. And we have to increase the memory and the processing power, and we're trying to work on tools for scalability to make this a bit better in time. So we don't have any great solutions right now other than to say to limit the number of people that are doing any jobs simultaneously, and we're learning more and more how we might scale this and allow it to support more simultaneous users. Andrew or Syed, or do you want to chime in a bit what your thoughts are on all this scalability and how it might support training? Because it's definitely been an issue for us.
Sure. So I mean, you already mentioned kind of our focus on scalability. Recently, one of the things that we've been looking at is getting some kind of administrative tools where during a training you can limit the size of regions and the number of tasks so that, during a training session, you say, hey, each user is only allowed to submit one task. When those are in the queue, then, it'll process that, which reduces the load on the system. And then, the flip side is, scaling the resources. And to a large extent, that's just a matter of buying more compute power from Amazon and throwing that at the system.
Thanks, Andrew. Yeah, so a couple things that you just mentioned that are important. We're looking at like taking the user interface and limiting, like you can't do an area bigger than 1 degree by 1 degree. We found that that is pretty much the sweet spot. Anything bigger than that starts to get a little large. So if you keep the size of your analyses small, that's one thing. And then the other thing we're thinking about is that any individual user that's logged in might be limited to only one job at a time. Or maybe at the larger scale, if there's 5, 6, 7 users logged in, maybe there's a limit on the total number of jobs that can be in the queue at any one time. So we're going to try to work on limitations for this. I think it's important for us to add some of these UI limits, and the size of the analyses, as well as the number of concurrent jobs, and number of jobs per person. All of that I think would help us make training and scalability run a little bit better. And you just might get a pop-up that says, hey, there's 5 people running jobs simultaneously, you need to wait before your job is allowed to be executed. That will always keep things running, and things won't crash.
Another question?
Anything else? We'll work on some of those UI limitations, and I know Andrew's been spending a lot of time doing that lately.
Okay, Brian, people asking you whether how frequently will it be available?
For us, for questions?
People, here we are from different organizations.
Right.
Then people want to know how possible can they communicate to you?
We can do training like this from time to time. I'm okay doing, some of these remote training sessions. If you want a session on how to use the user interface, walk people through. I would love it if some of the people that have witnessed this training in the last 3 days can start to do training on their own. And, I'm the trainer, so I'm hoping I have trained some new people to be trainers these last couple days. It would be great. So for instance, in Ghana, just this past week, we had Edward Boma, who has been working with us for several months. He actually conducted a training session where he did all the teaching. So he knew enough about the user interface and enough about interacting with the Ghana Cube that he conducted that training and taught other people how to do it. That would ultimately be where I'd like to go. I'd like you to become more proficient in this, and then you can help some of these folks. We can, still support this, but it becomes harder and harder for me to do so if I'm being asked by 5 countries constantly to provide training, then I spend all my time really becoming a training guru, which is not ideal. Now, another thing that's coming, the Global Partnership for Sustainable Development is hiring somebody. They are going to be living in Africa, probably Nairobi. I don't know exactly where, and they are going to be trained and taught how to use all DataCube stuff, just like I've, trained you guys the last 3 days. And when that person becomes proficient, they're also going to be a fantastic resource for you, because they're going to be an in-country resource that could possibly come to you and spend days with you and working with you face to face. So that's coming in the next few months. We're going to hire somebody full-time through the Global Partnership. So I hope that helps. In the meantime, send us emails. If you've got questions, if there's other people that need some training, send us those requests. Let's talk it over, and I'll see if I can accommodate the best we can. It's just it's difficult for us to do so with so many cubes running out there now. It's becoming harder and harder because it's becoming quite popular.
Okay,
so it's a good thing and a bad thing, right? The data cube's becoming popular.
Yeah, of course, it's becoming popular. Can
Very
we give
good.
Brian?
Yes.
May we have your email address?
Yes, you should have had it, but I'll put it on the screen for you.
Okay.
There it is. Brian D. Killo at nasa.gov. Got it on the screen. Got it on the screen there for you.
Now we are in the mail list, so we'll contact you.
Yes, and I'm in the mailing list, certainly. And, you know, a lot of things, if it gets a bit technical, I likely can't answer all of those, so I pass it forward to my team. And, you know, as we've got a community of people that are working the data cube, so sometimes, you know, we've got folks in Australia that are pretty proficient. There's people in various parts of the world that are becoming more proficient in this, so it might not always be us answering your question, and we're hoping that the community can start to weigh in on this.
So Brian, we are going to send you additional names to include in the Tanzania mailing list. I think we have participants who are not here last time.
Fantastic. Yeah, you know, I didn't think about that, was sending out. So if you send me those names, I'll add them to the mailing list. And when I finish compiling the video from today, we have videos from the last 3 days, and I have documents from the last 3 days. I can put all of that in an email out to the mailing list, and that everybody that was or wasn't here could have access to that.
Fantastic.
Sure, fantastic.
Yeah, because I think that mailing list is broader than the people that attended the last 3 days.
Okay. Otherwise,
yeah.
thank you very much.
Okay, fantastic, and thanks for your time in the last few days and the interactions. It's been great, and I hope to see many of you face to face someday. You know, I'll get my chance to make my way to Tanzania, and perhaps we'll have a face to face interaction.
Yeah, sure.
Fantastic.
We would appreciate.
My pleasure. All right, everybody, have a great evening, great day, and we'll talk again soon. Bye now.
And have a good day.
Bye.